Next problem.
A positional servo mechanism is characterized by an open loop transfer function g of s is equal to a divided by s into s plus alpha, where a and alpha are constants. Find the values of a and alpha so that zeta, damping ratio zeta is equal to 0.6, and frequency of damped oscillations equals 8 radians per second. Also find the peak value of the response when the system is excited by a step of 2 volts.
Excited by a step of 2 volts.
Solution. Let us read the problem once. A positional servo mechanism is characterized by an open loop transfer function g of s is equal to a divided by s into s plus alpha, where a and alpha are constants. Find the values of a and alpha so that zeta equals 0.6 and frequency of damped oscillations is equal to 8 radians per second. Also find the peak value of the response when the system is excited by a step of 2 volts. Given g of s is equal to a divided by s into s plus alpha. Assume alpha zeta is equal to 0.6 and omega d is equal to 8 radians per second. Assume h of s is equal to 1. Recall omega d is equal to omega n into square root of 1 minus zeta square. This implies omega d is given as 8 is equal to omega n into square root of 1 minus zeta is 0.6 whole square. So this implies omega n is equal to 10 radians per second. The system characteristic equation is 1 plus g of s h of s equal to 0. This implies 1 plus a divided by s into s plus alpha into 1 equal to 0. This implies s square plus alpha s plus a is equal to 0. Equation 1. The reference characteristic equation is s square plus 2 times zeta into omega n into s plus omega n square equal to 0. Comparing equations 1 and 2 gives 2 zeta into omega n is equal to alpha and a is equal to omega n square. Hence alpha is equal to 2 into 0.6 into 10 is equal to 12 and a is equal to 10 square. 10 square is equal to 100. So we have found the values of a and alpha. Next we have to find the value of the peak response when the system is excited by a step of 2 volts. Let me draw a step response. X axis is time, y axis is c of t. In the problem it is given steady state value c of infinity is equal to 2. This is the step response. This is the peak value of the response and this occurs at Tp is equal to at Tp. What is MP? We know that MP is equal to C of Tp minus C of infinity divided by C of infinity. This implies what is the formula for MP? E to the power minus pi into zeta divided by square root of 1 minus zeta square. This is the expression for MP is equal to C of Tp minus C of infinity is 2 divided by 2. Cross multiply and adjust. So you get C of Tp is equal to 2 into e to the power minus pi into zeta divided by square root of 1 minus zeta square plus 2. You know what is zeta? Zeta value is 0.6. If you substitute and simplify, you are going to get the expression for C of Tp as 2.189 volts. 2.189 volts. So this is how the peak response C of Tp is found. Next problem. Figure 1 shows a simple mechanical system excited by a force F of t is equal to 9 newtons. In figure 2, the corresponding step response is shown. find the values of M, B and K. This is figure 1. This is figure number 2. So let me read the problem once. Figure 1 shows a simple mechanical system excited by force F of P is equal to 9 newtons. In figure 2, the corresponding step response is shown. Find the values of M, B and K. Slightly tricky problem. Solution. The mechanical network corresponding to figure 1 is as shown below. We have only one displacement. Mass M is connected between x of t and ground. Damper having coefficient B is connected between x of t and ground. Spring having stiffness K is connected between x of t and ground. Force F of t equal to 9 newtons is given to node x of t. This I call figure number 3. At node x of t, M into d square x by dt square plus b into dx by dt plus k into x is equal to f of t. We'll take Laplace transform on both sides with all initial conditions equal to 0. Taking Laplace transform on both sides with all initial conditions equal to 0 gives M into s square into x of s plus b into s into x of s plus k into x of s is equal to f of s. This implies the transfer function x of s divided by f of s is equal to 1 over ms square plus bs plus k. This I call equation 1. This implies x of s is equal to f of s divided by ms square plus bs plus k. Equation 2. given f of t is equal to 9. Laplace transform of f of t is f of s is equal to 9 by s. Call this as equation 3. Substituting equation 3 in equation 2 gives x of s is equal to 9 divided by s into ms square plus bs plus k. According to final value theorem, x of infinity is equal to limit t tending to infinity and x of t is same as limit s tending to 0 s into x of s. This is the statement of final value theorem. From figure 2, x of infinity is 0.03. From figure 2, x of infinity is equal to 0.03. Hence 0.03 is equal to limit s tending to 0, s into x of s. What is x of s? X of s is what? 9 divided by s into ms square plus bs plus k. S gets cancelled. If you put s is equal to 0, you get 9 by k. So this implies 9 by k is equal to 0.03. This in turn implies k is equal to 9 by 0.03. 9 by 0.03 gives you k is equal to, the value of k is equal to 300 newtons per meter. This is the value of k. Next we are required to find the values of m and d. The values of m and d. The system characteristic equation is denominator polynomial of equation 1 is called denominator polynomial of equation 1 equal to 0 is called characteristic equation of the system. You take closed loop transfer function, its denominator you equate it to 0. That will give you the characteristic equation. So is what? ms square plus bs plus k is equal to 0. In the system characteristic equation, correct, the value of the coefficient of s square should be always 1. So I shall divide this equation throughout by m. So this implies s square plus b by m into s plus k by m is equal to 0. Call this as equation number 3. Equation number 3. The reference characteristic equation is s square plus 2 times zeta into omega n into s plus omega n square equal to 0. This is equation 4, I think. This I call equation 5. Comparing 4 and 5, comparing these two equations. Please check the numbers. Comparing equations 4, this is 4 and 5 gives 2 times zeta into omega n is equal to b by m. This I call equation 6, and omega n square is equal to k by m, equation 7. The next step in the analysis is to find find the values of zeta and omega n. The next step in the analysis is to find the values of zeta and omega n. MP is equal to x of Tp minus x of infinity divided by x of infinity is equal to e to the power minus pi into zeta divided by square root of 1 minus zeta square. This implies what is x of Tp? This is x of Tp. X of Tp is 0.03 plus 0.003 is x of Tp minus x of infinity is 0.03 divided by 0.03 is equal to e to the power minus pi into zeta divided by square root of 1 minus zeta square. In this equation, only unknown is zeta. So, solving, so this is MP. So, to find zeta, you can use the expression zeta is equal to square root of natural logarithm square of MP divided by pi square plus logarithm of MP square. So, MP is this value, correct? The only unknown here is zeta. So, solve for zeta. If you solve for zeta, zeta works out to be 0.59. From figure 2, what is Tp? Tp is equal to 2. We know that Tp is equal to pi divided by omega n into square root of 1 minus zeta square. This implies omega n is equal to pi divided by Tp into square root of 1 minus zeta square. So what is Tp? Tp is 2 seconds into square root of, what is zeta? Zeta is 0.59. 1 minus 0.59 whole square. So from here, we can, using this expression, we can find what is omega n. The value of omega n is 1.945 radians per second. Now we know zeta has 0.59, omega n has 1.945 radians per second. From equation 7, m is equal to what? M is equal to, equation 7, m is equal to k divided by omega n square. K is what? 300. What is omega n? Omega n is 1.945. Substitute. This is the value of omega n. Substitute. The value of m works out to be 79.3 kgs. Check the calculations. From equation 6. What is B? B is equal to 2 times zeta into omega n multiplied by m. So zeta is 0.59. Omega n is 1.945 and m is 79.3. You will get the answer as 182 newtons per meters per second. Like this, the problem is solved. So this is slightly involved problem, but this problem has been asked when the going is tough. When the question paper is tough, such problems appear. Please go through this problem once or twice, and if you have any problem to understand the concept, kindly contact me. We shall go to next problem. Next problem. Determine the values of gain K1 and velocity constant K2 shown in figure 1 by assuming MP is equal to 0.2 and time to take TP is equal to 1 second. Also find TR and TS. This is the block diagram. Let me read out the problem for you. Determine the values of gain K1 and velocity constant K2 shown in figure 1 by assuming MP is equal to 0.2 and TP is equal to 1 second. Also find TR means rise time, TS means settling time. The solution will start. Solution. Recall what is the formula for MP? MP is equal to e to the power minus pi into zeta divided by square root of 1 minus zeta square. This formula is useful for finding MP when zeta is given. Or this, when you simplify, you get zeta is equal to square root of natural logarithm square of MP divided by pi plus natural logarithm of MP square. I have derived this, you can go through the earlier problems. This formula is useful for finding zeta when MP is given. Equals, this implies zeta equals square root of natural logarithm of 0.2 square divided by pi square plus natural logarithm of 0.2 square. So if you find zeta, using this you find zeta. Okay. Then the value you find. Next we want to find what is omega n. Recall formula for Tp is equal to what? Pi divided by omega n into square root of 1 minus zeta square. Tp is given as 1 second. This implies 1 is equal to pi divided by omega n into square root of 1 minus zeta square. Now from here you can find zeta. Since zeta is known to you, can find omega n. Correct? This implies omega n is equal to, you find. Zeta is dimensionless. The system characteristic equation is 1 plus g of s h of s equal to 0. This implies 1 plus k1 divided by s into s plus 1 into 1 plus k2 into s equal to 0. So take LCM, you get s square plus s plus k1 plus k1 into k2 into s equal to 0. This implies s square into 1 plus k1 k2 into s plus k1 equal to 0. This will call equation 1. This will call equation 1. The reference characteristic equation is s square plus 2 times zeta into omega n into s plus omega n square equal to 0. This is equation 2. Comparing equations 1 and 2, gives 2 zeta into omega n is equal to 1 plus k1 k2 and omega n square is equal to k1. Solve for k1 and k2 since zeta and omega n are known. I have given you the procedure, are known. The answers also I will give you. K1 equals 12.5 and K2 is equal to 0.178. Please check these answers. The procedure is correct, but the answers you please cross check. The values of zeta and omega n you have to find. Substitute those values in these two equations and solve for K1 and K2. This is the answer for K1 and this is the answer for K2. Next we have to find rise time. To find rise time. What is the formula for phi? Phi is equal to tan inverse of square root of 1 minus zeta square divided by zeta. This must be in radians. Put the calculator in radian mode and calculate phi. Formula for TR is equal to pi minus phi divided by omega n into square root of 1 minus zeta square. You know what is phi, you know what is omega n, you know what is zeta. The answer for TR will be 0.65 seconds. Next to find settling time TS for plus minus 2% tolerance band, for plus minus 2% tolerance band, settling time Ts is equal to 4 divided by zeta into omega n. You know what is zeta value, what is omega n value. Substitute, you will get the answer as 2.48 seconds. With this, we conclude this problem. Next problem. Refer the mechanical system refer the mechanical system shown in figure 1. Shown in figure 1. This is the mechanical system. K, B, M. Force is excited by, mass is excited by force F of t newtons. Displacement of mass m is x of t. The value of m is 3 kgs. The value of d is 15 newtons per meters per second, and value of k is 33 Newton meters. This is figure number 1. The values of m, b and k are given. M is equal to 3 kg, b is equal to 15 newtons per meters per second, and k is equal to 33 Newton meters. Part A. Find the transfer function. Find the transfer function x of s divided by f of s. Find the transfer function x of s divided by f of s. Part B. Find the values of zeta, omega n, TR1, TP and TS. This is the problem. Solution. These are all application based problems, and let me read the problem once again. Refer the mechanical system shown in figure 1. Find the transfer function x of s divided by f of s. Part B. Find the values of damping ratio zeta, natural frequency omega n, rise time TR1, time to peak TP, and settling time TS. Solution. The mechanical network corresponding to figure 1 is as shown in the figure below. We have got only one displacement, therefore one independent node x of t. The other node will be the reference node. Mass m is connected between x of t and ground. Damper is connected between x of t and ground. Spring is connected between x of t and ground. To node x of t, we inject the force F of t. This is the mechanical network. From the mechanical network, we can write F of t is equal to force entering is equal to sum of the forces leaving. So m into d square x by dt square plus b into dx by dt plus k into x. Taking Laplace transform on both sides, with all initial conditions equal to 0 gives f of s is equal to m into s square into x of s plus b into s into x of s plus k into x of s. This implies x of s divided by f of s is equal to 1 over ms square plus 1 over ms square plus bs plus k. Substitute the values of m, b and k. So m is 3s square, b is 15s plus k is 33. This is the answer for part A. If you take s common, if you take the coefficient of s square common in the denominator, you get 1 by 3 is what? 0.33 divided by s square. 15 by 3 is 5s plus 11. So the transfer function is 0.33 divided by s square plus 5s plus 11. Part B. The system characteristic equation is denominator polynomial of the closed loop transfer function equated to 0 is called characteristic equation. So in this case it is s square plus 5s plus 11 equal to 0. This I will call as equation 1. The reference characteristic equation is s square plus 2 times zeta into omega n into s plus omega n square equal to 0. Equation 2. Comparing equations 1 and 2 gives comparing equations 1 and 2 gives 2 into zeta into omega n is equal to 5 and omega n square is equal to 11. Hence, omega n is equal to root of 11 radians per second, and zeta is equal to 5 divided by 2 into omega n. 5 divided by 2 into root of 11. 5 divided by root of 11 is 0.754. So we know the values of delta and zeta. Next is rise time. Rise time TR1. Formula for TR1 is 1 minus 0.4167 zeta plus 2.917 zeta square TR raised time TR1 divided by omega n. This has to be used only when zeta lies between 0 and 1. That means only for an underdamped system. You know what is the value of zeta? Substitute, you will get the answer 0.69 seconds. Please check the correctness of these answers. TR1 is equal to 0.69 seconds. Next I will calculate peak time. Peak time Tp is equal to pi divided by omega n into root of 1 minus zeta square. You know what is omega n, you know what is zeta. You substitute, you will get the answer as 1.44 seconds. Last one, for plus minus 2% tolerance band. For plus minus 2% tolerance band, settling time Ts is equal to 4 divided by zeta into omega n. You know what is zeta value, what is omega n value. Substitute, you will get the answer as 1.6 seconds. Please note, settling time Ts should be greater than peak time Tp should be greater than Tr1. Otherwise, check the calculations. Thank you. Refer, next problem, refer the prototype system shown in figure 1. Take the values of zeta equal to,
Take the values of zeta and omega n.
zeta and omega n as 0.6 and 5 radians per second. Find the values of TR, TP, TS and MP. This is the block diagram of the prototype system. Omega n square divided by s into 2 times zeta into omega n plus 1. H of s is equal to 1. Unity feedback system. Sorry, this is plus s. This is the unity feedback system. We have been given solution, given zeta equals 0.6 and omega n is equal to 5 radians per second. So first we will calculate what is rise time Tr. Phi is equal to tan inverse of square root of 1 minus zeta square divided by zeta. Put the calculator in radian mode. Phi must be in radians. What is the formula for Tr? Tr is equal to pi minus phi divided by omega n into square root of 1 minus zeta square. You know what is phi? You know what is zeta? You know what is omega n. Substitute and take out the answer. The answer is 0.55 seconds. Next we go to peak time. Formula for peak time is Tp is equal to pi divided by omega n into square root of 1 minus zeta square. You know omega n value is 5, zeta value is 0.6. Substitute. You should get the answer 0.785 seconds. Please note that Tp value should be higher than Tr value. Next is settling time. Settling time Ts is equal to 4 divided by zeta into omega n. This is for plus minus 2% tolerance band. If you substitute zeta and omega n values, you get 1.33 seconds. Last one is peak overshoot MP. Formula for peak overshoot MP is equal to e to the power minus pi into zeta divided by square root of 1 minus zeta square. Value of zeta is 0.6. Substitute, you will get the answer as 9.5%. Into 100 I have done. If you multiply the value of MP on the right side to 100, you get percentage overshoot. Percentage overshoot is 9.5. With this, we have done fairly a good number of problems. Please revise these problems as many times as possible, because in this module the questions will be very straightforward in the examination. Thank you.